All right, today we're playing Cosmic Detective. We're heading out into the universe to investigate some of its oldest, most fascinating cold cases. So let's grab our magnifying glasses and take a look at the evidence. I mean, think about it. It's the ultimate challenge, isn't it? The crime scenes are literally light years away, and the events we're talking about happened long before humans were even a thing. But just like detectives here on Earth, astronomers look for clues left behind. And let me tell you what a crime scene it is. The clues can be anything, from tiny molten droplets locked inside a meteorite to faint ripples in space-time itself. So today we're going to dive into three incredible cases that'll take us from our own backyard all the way to the edge of a black hole. Okay, our first case starts close to home, right here in our very own solar system, with a planet we all know and love, the gas giant Jupiter. For years, scientists have been trying to nail down exactly when Jupiter formed. Figuring out its birthday is absolutely crucial for understanding how our entire solar system grew up. The problem? Well, the trail went cold about 4.5 billion years ago. So where do you even start looking for a clue that old? Well, it turns out you look inside meteorites. Specifically, you look for these tiny little spheres called chondrules. You got to think of them as perfect little time capsules, usually no bigger than a couple of millimeters, that hold the secrets of the baby solar system. But how did they get there? Okay, so here's how it all went down. A young, rapidly growing Jupiter started getting massive, and its gravity began flinging around these rocky and icy objects called planetesimals. They're basically the building blocks of planets. This chaos led to some incredibly violent, high-speed collisions. Now, what's really cool is the role water played. When these objects, rich with water, smashed into each other, the water instantly vaporized, setting off what researchers call tiny explosions. This process blasted molten rock out into space, which then cooled into those little spherical droplets we now call chondrules. So by analyzing these chondrules, scientists found that their production went way up at a very specific time, a time that lined up perfectly with Jupiter's most intense period of growth. And boom, that pinpointed its birth to just 1.8 million years after the solar system began. Case closed. These little chondrules are Jupiter's molten fingerprints left at the scene of the crime. All right, let's zoom out from our solar system for our next case. This one takes us about 3,400 light years away to a truly stunning object known as the Butterfly Nebula. And the mystery here? It's even more fundamental. We all know rocky planets are made of cosmic dust, right? But what kind of dust? And how does it even form? Well, the James Webb Space Telescope has given us this absolutely unprecedented look inside this nebula, and it's revealing clues about the very building blocks of worlds just like ours. So inside the Butterfly Nebula, scientists found two totally different kinds of dust. On one hand, you have these beautiful crystalline silicates. They're basically microscopic gemstones that form in calm, stable environments. But on the other hand, you've got this irregular soot-like dust, what researchers call fiery grime, and it's created in much more violent, fast-moving regions. Finding both of these in the same place is a huge deal for understanding how the raw materials for planets get made. But that's not the only clue they found. Okay, so this sounds like the setup to a really weird joke, right? But the answer actually points to this profound discovery about the chemistry of the entire cosmos. The answer is these things: polycyclic aromatic hydrocarbons. Yeah, that's a mouthful, so let's just call them PAHs. They're these complex carbon-based molecules with honeycomb structures. And here on Earth, you find them all over the place, in the smoke from car exhaust, from campfires, and yep, even on burnt toast. They're a key part of that grime we were just talking about. And here's the real mind-blower. Scientists had never, ever seen PAHs forming in an oxygen-rich environment like this one. This discovery suggests that these crucial carbon-based molecules, the very stuff planets and maybe even life are made of, can actually form in a much wider range of cosmic environments than we ever thought was possible. It's like finding a key ingredient for a recipe in a place you were told it just couldn't exist. For our final case, we're going deep. We're venturing into the realm of the truly invisible, hunting for a suspect that leaves no trace, except for its influence on the very fabric of space-time. Yep, we're talking about gravitational waves. So back in 2019, our detectors picked up this signal, GW 190814, from two merging black holes. But something was off. The two black holes were wildly mismatched. One was about 10 times more massive than the other. A 10-to-1 ratio like that was a huge puzzle, and it hinted that this wasn't just some simple, isolated merger.
So the detectives on this case, a team from the Shanghai Astronomical Observatory, they went back to the data, and they found this incredible clue, a Doppler fingerprint hidden in the gravitational waves. You know how the pitch of an ambulance siren changes as it moves towards you or away from you? Well, it was the same idea here. The frequency of these waves was shifting, which meant the two black holes weren't just orbiting each other. The entire system was accelerating through space.
There was really only one explanation. Something else, something massive and totally unseen, had to be pulling on them. The prime suspect? A third enormous object, probably a supermassive black hole lurking nearby, its immense gravity yanking the smaller pair towards their final collision. And the evidence was just overwhelming. When the scientists ran the models, comparing the event with this third object versus without it, the results were just staggering. The odds were 58-1 in favor of the hidden giant actually being there. In the world of astrophysics, that's not just a clue, that is a smoking gun. Just as the lead researcher, Dr. Wenbiao Han, put it, this discovery fundamentally changes how we think these mergers happen. It turns out these binary black holes might not be so alone out there after all. So, after investigating 3 totally different cosmic crime scenes, what have we learned? How do all these seemingly random clues connect? Well, we've seen that the evidence is literally everywhere, and it comes in all shapes and sizes. We're talking tiny molten droplets that tell us when a planet was born, to microscopic crystals and organic molecules that hint at how planets get built, all the way to these subtle fingerprints in gravitational waves that reveal invisible giants hiding out in the dark. You know, the really big takeaway here is that we're living in a golden age of cosmic detection. With these powerful new tools, like the James Webb Space Telescope and gravitational wave observatories, we're piecing together a universe that is so much more dynamic, complex, and interconnected than we ever imagined. Every single particle and every single wave has a story to tell. And that really just leaves us with one final exciting question, doesn't it? The universe is absolutely full of mysteries, but our tools for solving them are getting sharper every single day. So, what century-old puzzle or billion-year-old cold case will these cosmic detectives crack open next?